Okay, now that we know some of the basic interface things and how to open up Matlab and work in the command window and look at what variables are present and things like that, let's start looking at how to do some simple calculations. So we're going to do most of this in the terminal, in the command window here. So Matlab can do just very basic computations. So 2 plus 3 times 4. The shift 8, that star, is the multiply operator, so we can do computations like that. To do division, you just use a slash, so this quantity that is computed, T2 equals 2 plus 3 divided by the quantity 4 times 5. This is the division operator. If you want to raise a number to a power, you can use shift 6. That is this caret symbol. That means 2 raised to the power 5. 2 raised to the power 5 is 32. So that's the answer. We get 32. Matlab has all the built-in trig functions that you could want. So if you want to evaluate the cosine of an angle, you can easily do that just by doing cosine of the desired angle. One important thing to keep track of in Matlab is all the angles are in radians. So pi over 4 is 0.7854 radians. In terms of degrees, you can convert to degrees by multiplying by 180 over pi. That is 45 degrees. So when you call cosine and trigonometric functions in Matlab, just make sure you call them with radians. If you call it with degrees, you're going to get a very different answer, and it's going to be very wrong. There actually is a cosine D, which means cosine in degrees. So you can use those if you want. If you want to use degrees, you can do that. But if you're just kind of typing things out and you're not familiar with Matlab, you'd probably type cosine, and you just need to know that that angle needs to be in radians, so don't make that mistake. Not only do we have cosine and sine and tangent and all the ones you think that we would have, there's also all the inverse trigonometric functions as well. So a cosine gives us the inverse cosine. So if you remember, T4 was 0.7071, which was what we got by evaluating the cosine function at 0.7854. So the a cosine gets us back to 0.7854, so that's the inverse cosine function. Matlab has the square root function, so if you want to compute the square root of 2, you can just use the square root function. You could also compute it by 2 to the 1/2. Those are equivalent things. Matlab has the exponential function, so remember what E is. E is just a number. E is the number, actually we can look at it with more precision this way, 2.71821, and it just keeps going on forever. So E raised to the power 2 is going to be something a little bit less than 9, a little bit above 7, 7.39, so that's the exponential function. Matlab has also all the logarithmic functions built in. One thing to keep in mind, though, is that this log is the natural log. So I would have been tempted to type something like ln, but in Matlab we actually type natural log as log. So since this is the natural log, this will actually perfectly undo the exponential operator. So we get 1 because these basically are inverses of each other. So we just return the argument. So just keep that in mind. The log function is the natural log. If you want to do base 10 operations, you have to use log 10. So log 10 is the base 10 logarithm, and sometimes we use those. And there are tons of other functions. These are just some of the common ones you might use. There's also a round function, so if I want to have a number and round it to the nearest integer, I might do something like that. Use the round command. The ceiling command always rounds up, so the ceiling of 1.1 is 2, the ceiling of 1.0001 is 2, because it takes us to the nearest integer always up. Remainder gives us the remainder of a division operation. Cosh is the hyperbolic cosine. Tan h is the hyperbolic tangent. You can take the real of a complex number, 3 plus square root of -1 times 2. So the real part is 3. The imaginary part of this number is 2, because 3 plus square root of -1 times 2 is this complex number, 3 plus 2i. The square root of a -1 is i. You could take the angle of this complex number. So there's lots of just built-in commands like this. Conjugate of this number makes all the j's go to negative j's. So all of these are just kind of examples of what I kind of think of as kind of calculator commands that you can use in Matlab. There are a lot more than this available, but these are the types of things that you'll start off doing.